Hello, everyone. Welcome to the webinar on rest and relaxation, best practices for stress-free RESTful development. My name is Michael Smart, Senior Support Specialist in the WRC. With me today is Kyle Baxter, my fellow Senior Support Specialist, who will be taking your questions during the webinar. So head on over to the Questions tab and send those in over the next half hour or so. We'll have some time at the end. I'm going to answer those as best I can for you live on camera. And just to let you know, this is going to be recorded and posted later on learning.intersystems.com. So don't worry about missing anything. You'll be able to watch it all again later. Now, before I begin, I'd like to take a moment to thank you for choosing to learn more about REST, whether you're creating a new application or enhancing an existing one. I think you'll come to appreciate the flexibility and simplicity of this approach. If your background is in CSP or Zen, which are the web technologies that we provide, then you know that it's very easy to create a fully dynamic web application very quickly. We've taken away all the behind-the-scenes work, things like connecting the client to the server to retrieve your data. But if you want to take advantage of some of the new frameworks in JavaScript that are available, things like AngularJS, React, and so on, you'll find that having REST as your back end is a better fit. If you have an application developed in Java, you're using our JDBC driver to connect and retrieve your data. And if all you're doing is just running queries, executing SQL commands, then that makes a lot of sense. But the downside is you're depending on a lot of moving parts working together simultaneously to give you your application. And so to give you an example, if the version of Java changes on your server, you might find that you need to update the version of the JDBC driver and even the version of Ensemble that you're using in order to restore compatibility and get things working again. The advantage of using REST as your interface for either of these types of applications is that you're not dependent on any library or intricate protocol. You're just making HTTP requests to some server to work with your data. Because there's an emphasis on stateless design for your service, it encourages you to modularize your code, which makes things easier to develop and test. Plus, if there are connection problems between your application and the server, it's easier to recover from those as opposed to a more stateful protocol. And finally, because you now own the interface between the client and your data, instead of relying on some library, if some incompatibility does arise, it shouldn't be something that will take you very long to identify and fix. So over the next half hour, we're going to review some best practices for developing a REST service. And we're going to do that in 3 steps. First, I'll talk about design, things you need to take into consideration before you even begin writing code. I'll then walk you through an example of a REST service that I've developed, which displays many good design principles. We have some advanced topics for you at the end, things to be aware of as you move into a production environment. And then, as I said, we have time for your questions. And just to let you know, the REST functionality that I'll be showing you today is compatible with all of our products, whether it's Cache, Ensemble, HealthShare, or InterSystems Iris data platforms. So let's begin by talking about design. If you're not familiar with REST, it's basically a series of guidelines or best practices for creating a web service built on top of the HTTP protocol. So as you might expect, it helps if you follow some of the conventions of HTTP. There's an expectation of things that will occur when certain types of requests are made. And so the best way to demonstrate that is really to just show you an example of a REST service, how it looks from the outside. I'm not going to show you any code yet, but let's pretend that we're a travel agency and our REST service is the interface to the database where we're keeping track of travel reservations made by our customers. And this is Postman, by the way, if you haven't seen it. It's kind of the industry standard for testing a REST service. And what I'm going to do is just make a GET request to my server for something called reservations. Now, just with that information, you might expect that what we're going to see in response is a list of those travel reservations, everything we have on file. And that's exactly what we see. There's a list right here. If I choose to get information about a specific reservation by its ID, we can now drill down and take a look at more detailed information about that reservation. So I've changed the address to point to a specific reservation. If I keep that address the same and instead change the type of request that's made to a put request, if I go here, I'm sending some data to the server, and what you might expect will happen is that we're going to replace what's there with this information, the new data being sent in. And again, that's exactly what happens. So this, I hope, illustrates the first best practice that I want you to be aware of. When you're designing your REST service, you want to orient the different requests that you expect to get around the idea of resources. What are the different types of data that you're going to be working with? And maybe just have the names of those pieces of data in your request, in your URLs. And then you can differentiate based on the type of request that was made, the HTTP method, these things here, to decide what the requester wants you to do. So there's two parts to every HTTP request. As I said, there's the method, or verb as it's sometimes called, and then the resource, the thing on the server that we're going to be acting upon. So deciding what the pattern of these requests are going to be is kind of an art, but I'll walk you through some considerations for doing that. So let's talk about HTTP methods. I've listed 5 of the most common methods right here, and also their correlation to some expected action on the server. If your background is in SQL, I have a third column that shows the SQL commands that would correspond to these actions. Now, you may be familiar with these, except for the patch. That's kind of a new entry to the standard, relatively new. And the difference between a patch request and a put is that a put request, we're indicating that we want to replace the entire record on the server with the new data being sent in. But a patch request, that only indicates a partial update. We're going to change maybe 1 or 2 fields, maybe all of them, but we have the option. Now, in addition to choosing your HTTP method based on the expected activity, there are other things you need to take into consideration, such as, based on the HTTP standard, can we expect that calling the same request multiple times will have the same end result on the server? Furthermore, do certain types of requests effect change to the data on the server? And these concepts are referred to as idempotence and safety. If a request is idempotent, that means we can make it a number of times, and the result is going to be the same. So as you might expect, 3 out of these 5 are idempotent. If we request data over and over, the end result is we're just going to receive that data. That nothing different is going to happen. We're not going to change any information. If we try to delete a particular record 5 times, well, if it works the first time and the record is now gone, the subsequent requests will not do anything. There's no change in the activity, whether it's done 1 time or 5 times. And as you might expect, of these 5, only the GET request is considered safe. There's an expectation that the other 4 will change some piece of the data. But just retrieving information shouldn't change anything. Let's move on to the resource part of things. We have 2 options here for retrieving information about travel reservations. 2 different resources we can use. Now, it's a GET request either way because we're retrieving data. So the GET reservations option is a little redundant. We don't need to have the activity in the actual resource name. The HTTP method will tell us enough, will tell the server enough, I should say, as to what we expect to happen. So if you can think of the HTTP method as the verb, then the resource names might as well be the nouns. So words like get or create or update really shouldn't be in your resource names. If you want to point to a specific record, the way you do that is by indicating its ID right in the resource name, right in the URL. And this ties into the concept of statelessness, which will be another best practice. All of the information that the server needs to process a particular request should come in the door with that request. We don't have any concept of remembering the client's state as they go through the application. It's up to the client to do that, to keep track of all the different things it's doing. So all the information the service needs, like the ID of the request that we're acting upon, should come in with the request. So that's something that can help you as you're designing your resources and also writing code. All the information you need should be there. So now I'm going to spend a little time and talk about how to write one of these things. What does the code look like? Just as a reminder, if you want to set up a REST service with Cache or Ensemble or any of the products, what you need to do is create a web application right here from the management portal. As you see, we have the REST and Relaxation travel agency application. And what you need to do is devote that application to your REST service exclusively by setting the dispatch class parameter. So right here I have rnr.service. And I'll now show you what that looks like in Atelier. We have the rnr.service class. We have our URL map with some routes, some of the different requests we expect to handle. Now, you might not be as familiar with this syntax, the map. What does this refer to? Well, in our URL map, we're trying to match the pattern of a particular request by its resource name and HTTP method with something in the map. If we receive a request that matches one of these prefixes, like, for example, travel v1, we're going to route that request to a second dispatch class instead of dealing with that right here. And this is called request forwarding. It's a very powerful feature. It can help you to isolate different parts of your application based on what they do. And another possible option is the way I'm using it here for versioning, for having multiple versions of the same interface available at the same time. So you could think of something like legacy compatibility. We want to keep an older version of the API running while we also offer the newer option. Now, the way I'm using it is to give multiple versions of the same REST service. That is, the dispatch class does the same thing to the database, but with increasing amounts of complexity. And this is going to demonstrate some more development best practices. We have 3 versions. There's one, the simple version of the class, which honestly is kind of the bare minimum in terms of implementation. There's going to be some glaring problems with this, as we'll see. We're going to try to address some of those in the improved version of the class. And then finally, in the best practices class, I'm going to show you the full extent of what you can do by following good development and good design principles. So let's begin with the first version. I'm going to show you 3 different types of requests, and we'll take a look at their code and compare and contrast, OK? So first one, what happens when we retrieve the information for a specific reservation? We have the ID right here, our argument, which came from the URL map. And the first thing we do is just open up the reservation object. And then knowing that we want to return that information in JSON format, we have a dynamic object that we create with the different key value pairs we want to return. And then we output that to JSON format with this method right here, %2JSON. If I show you in Postman how that works, we'll switch to the v1 API. It's going to be a GET request. I'll just grab some of that data. And you see we got our response. The problem with this method, as it exists right now, you might have seen it in the code just a moment ago, but we don't actually check to see whether that reservation object exists before we do anything else to it. So if I change the URL to point to an ID that does not exist, here's what we get. And this is what happens, by the way, if you don't trap your errors properly or if you return an invalid status from one of your dispatch methods. You get this cache stack trace. Now, this accurately describes the error, in a sense, invalid oref. So we're referring to an object that is not open, that doesn't exist. But there's 2 things here. First, 500 internal server error is not the most accurate representation of the problem. We'd rather have 404 not found, right? The record doesn't exist, so let's just be simple about it. And second, it's always better if we don't expose the internal workings of our error handling. We'd like to have our own methods, our own messages, rather, to take control over what the client sees. I mean, this is fine for development, but in a production situation, you might not want people to see this. So we can address those problems like this. I'll show you the improved version of that class, the getReservation method. We're just going to check to see if the object we opened actually exists. If not, we return 404 not found as our response status. So if I change that to v2, run the request again, you're going to see 404 not found. So that's better. Now let's look at how we can create a new reservation, which is right here. The first thing we need to do is grab the contents of the incoming message, the request body. We're expecting that to be in JSON format, so we're going to call the %fromJSON class method, give ourselves a dynamic object to work with. And then the following lines are pretty straightforward. We just create a new record in the database, randomly generate an ID for that reservation, and then set the properties that came in with our request, and then save it. So back in Postman, we'll go back to v1, make a post request. I'm just going to duplicate this record. That's totally fine. We'll save that. We got a 200 OK. Now, the problems with this method are a little more subtle. But this first line right here, where we're converting the incoming message, I said we expect it to be JSON, and we want to get a dynamic object back. But what if what we got was not JSON, or it's invalid JSON? I can show you that by just taking off the trailing curly brace from our message. We'll try to post that again. And we got another 500 internal server error. Premature end of data. Now that's accurate to the situation, right? The JSON message is invalid. It wasn't closed properly. But again, we'd like to maybe return a simpler error message that's a bit more accurate to this situation. So what I can do is actually trap that error by wrapping the method call in a try-catch block. And if we don't get a dynamic object back from the %from JSON method, we want to say bad request, which more accurately describes the situation. So if I change that to v2 and post again, we're going to see 400 bad requests. Now, I said there were two problems. The second one is that we're not really doing any data validation, any input validation. So if I clear out one of these fields, this is actually going to fail the data model validation a little further down the line. So if I try to post that, you're going to see end date required for the reservation. So it would be nice if we could do some validation of our inputs. That's kind of an enhancement to this code that we're going to make in a few minutes. And I'll show you a nice, concise way to do that. But let's move on to our third method. Let's do the patch, the partial update. So just from looking at this code, you can see we're kind of doing the same things that we've done before right at the start. We need to grab that request body, create a dynamic object based on what we hope is JSON. We need to open a reservation object based on some ID, and then we're just doing updates based on what was sent. We only update the field if it came in with the incoming JSON. Now, we're repeating ourselves a little bit, which brings me to yet another one of our best practices. That's DRY. Don't repeat yourself. If you find that you're writing the same code blocks over and over, those are good candidates for helper methods. You write it once and then just call into it. So I'll show you what I mean. Here's the pseudocode representation of those three methods, those three requests that we just looked at. So in 2 out of these 3 cases, we're opening a reservation object based on some ID. But if it doesn't exist, we want to let the user know about that. In 2 out of these 3, we're grabbing request body information, hoping it's JSON. If not, we want to return some error to let the user know that their request was bad. To that point, we handle a lot of errors in different parts of the application. So the standard way of doing things is to try something and then check to see if it worked. If not, handle the error immediately, send back the HTTP response. But a better approach might be to have one piece of code, one section that handles all of our errors, especially when you're dealing with REST, where the operations are so simple. You don't really get into a situation where it's possible to recover from an error. It's often best to just tell the user what went wrong and let them try to fix it. So what can we do to make that a little better? We can use exceptions. And the power of this approach comes from combining the two practices together. So I'll show you how that works. We're going to rewrite our dispatch class so that each one of the methods will call down to other functions to do the updates and different things that we have to do. That's going to improve readability because we can have our methods be named accurately to some single activity. So just at a glance, you can see what the thing does. And we're going to have modularized code. It's always better to have less code than more. There's less chance of bugs being introduced. It's easier to test things. If we have errors come up in these helper methods, these utility methods, let's just throw an exception instead of trying to deal with the error right there. And the dispatcher will be responsible for catching those exceptions. We'll have a try-catch block in each case. When we catch one of those exceptions, we want to set the HTTP response status code based on what happened. And to that point, we know certain situations that can occur, things like the request, the information you sent was bad, we can't work with this. The reservation you tried to look at doesn't exist. So we can actually just create custom exception classes for those cases. And that's exactly what I've done in the 3rd edition of this class, the best practices version. So let's step through this, and I'll show you what we've got. To get a reservation, we're going to jump down into this utility method called open reservation. I have a whole class for all of my helper methods, by the way. Build up our dynamic object just like before, and we're hoping everything goes well. But if not, we're going to be in our catch block here where we have a single error handling method. Let me show you both of these things now. To open a reservation, we just do the same thing as before. We check to see if it exists, and if not, instead of dealing with the error right here, we throw an exception. We have our custom not found class right here. And I'll show you what that looks like. It's very simple. This is all custom exception classes that I've created. And we have two parameters. We have the HTTP status that we want to return, and then an additional option to log this error if we want to. In this case, we're saying, no, it's not that important to record information about a 404. But in some cases, we do want to write that information down for later debugging. So I'll show you the error handler now. It's at the bottom. All we do is check to see whether the exception we just got is one of our custom exceptions. We set the status code accordingly based on that parameter, and then we decide whether or not we want to log the error based on this parameter. And that's going to appear in the application error log. We have a little piece of JSON that we send back with information about the error, what went wrong. And then if it's a traditional error that we've trapped just as a result of some other issue, we say 500 internal server error. And we return just one error message, not the full stack trace. Back here in the class, I'll show you how we create a new reservation object. We have a helper method to grab the JSON data, the request body that's been converted to a dynamic object. And then we call this create reservation method. I'll show you both of those. If you want to grab JSON information, we have a try-catch block that either returns the dynamic object or throws an exception. And then here under create reservation, I'll show you what I mean by readability. We have some methods with kind of long names, but they accurately describe what happens. We want to set the properties of our reservation object based on what was sent, the dynamic object. Then we want to validate the reservation before we save. So we're going to check things like, are each of the required fields, are any of those required fields empty? Do we have logical problems, like the start and end date of our trip are not in the correct format, or the start date comes later than the end date, which wouldn't make any sense? These are things that are very easy to check. We can write a strong validation method if we write it once and then just call it everywhere we need it, anytime we save. And I'll show you the patch at the end here. Very simple. We grab the JSON data again, and then we have an update reservation method, which looks a lot like the create reservation method. But it's easy to just scan with your eyes and read to see what this thing does if you name your methods appropriately. Now, I know that some of you will want to take a look at this code in some more detail, and you certainly can. It's available right now on our GitHub account. Go to github.com/InterSystems and look for the REST and Relaxation repo, where we have the best practices version of that class available for you to download and test. Now let's go over some of the advanced topics. These are cases that won't affect every REST service that you try to develop, but they are important, and we want you to be aware of these. And the first one is CORS, CrossOrigin resource sharing. This is a potential security problem that affects web applications, web browsers. So listen up if you are planning to develop a REST service in conjunction with a web application. I'll show you how this works. When you make a request to a web application, you're going to download some JavaScript. And that JavaScript will tell your browser to make additional requests to gather other pieces of information, like, for example, from a REST service. Those second requests made by your browser because of JavaScript, we're going to tell the REST service who we came from. Which web application were we looking at that caused this second request to the REST service? And that's called the origin. It's included in the HTTP header. So we're saying, who told me to talk to you, the REST service? Now, if the origin of the request is the same as its destination, that is to say, the web application and the REST service are hosted by the same web server, we call that a same origin request. And by default, with our REST service, those will work. However, if we were browsing an application on a different web server, a different website, not related to our REST service necessarily. That JavaScript code comes back and tells us to call the REST service. But our origin is now going to be different. It's a different website. And so by default, this CrossOrigin request, as it's called, will fail. We're going to say we don't want to provide the response for that request. Now, that all works fine, but in some situations, you may find that you need to allow some cross-origin requests to retrieve data from your REST service or manipulate information. So what you can do is enable CORS support with either the handle CORS request parameter in the dispatch class, which will enable it for all of the routes in your URL map, or you can enable it on a per route basis by setting the CORS equals true attribute in your URL map. But there's an important second step when you do this, because by default, enabling CORS in that way will allow requests from any origin to make it into your service. And the security issue here is that maybe some web application that should not have access to your data would be able to, in a sense, trick a user's web browser into retrieving information, and maybe it's private information. Send that back to some third party which should not have it. That's why this is important. So if you want to set up a whitelist, only allow certain origins to come in, you need to override this method, onHandle CORS request, and then check the origin and set your whitelist accordingly. So this is something you definitely want to educate yourself about. It's very important if you're writing REST services aimed at web applications. And I urge you to just do a search in our documentation for onHandle CORS requests. You'll see a nice page that describes how to set that up. There's plenty of resources out there online that can tell you more about this situation. Let's move on and talk about authentication. How do I set it up so that users calling into my REST service need to authenticate themselves, to provide a username and password before they can come in? There's two steps, or rather two sides to the equation, let's say. The first is you need to lock down your REST service, and you can do that by going back to the web application page here. There's a section for allowed authentication methods. What you want to do is uncheck unauthenticated and then check off password or one of the other boxes that may appear here, depending on your security model. If you have delegated authentication in your system, for example, you'll want to check that if that's what you use. So actually, I can just turn this on, and I'll show you how it works. The second side of the equation is you have to authenticate yourself. So if I make a request to that service again, that's going to come back with 401 unauthorized, which means we're not providing any username and password yet. We need to set up basic authorization. And what this does is, this is a kind of a nice feature of Postman. You say you want basic authorization. That will set up the appropriate HTTP header with the basic authorization string to actually send those credentials to the service. But more important than the technical aspects of authentication is a side effect that comes about when you send this type of information to the service. And that is that your username and password will be sent across in plain text, which means anyone looking at your network traffic, it's very trivial for them to just harvest not only information being sent to and from your REST service, but user accounts. So you absolutely, positively must set up HTTPS for any kind of production REST service. Even if you're behind a firewall, even if you think there's no way that anyone could get in and look at this traffic to see this information. It's in this day and age, you absolutely need to protect yourself. So I would encourage you, especially if you're having users authenticate in this way, in order to protect their login details, you need to use HTTPS on your web server. So the final topic of the day is going to be caching. Some information doesn't change very often, and it would be nice if the REST service could let clients know that it's OK to save your own local copy of this response data, and then you don't need to request that information from the service again for some period of time. And I'll show you how that can be done. If I go back to the service class here, I have a method that gives you a list of travel destinations. Let's say this isn't going to change very often. The service needs to let the client know that first it's OK for you to cache something, and then for how long. So I have 24 hours here in seconds. And I'm setting two parameters of the response object, which are going to be reflected in the HTTP headers of that response. First is the expires field. And second is the cache control HTTP header, where I'm saying in both cases, yes, it's OK to cache this information for 1 day. Now, it's difficult to show you how this works because ultimately it's up to the client to decide whether or not they want to cache something. All you're doing as the service is keeping up your end of the bargain. You're saying it's OK for you to cache this if you want to. So Postman doesn't cache anything because it's a testing tool. It's designed to always make requests to your REST service. I would show you how this works in the Chrome network tab, the developer tools, but it seems like that's not doing what we want and caching this information despite what we say. So ultimately, it's up to the client to write code that checks the HTTP headers and then decides what to do. So let's go over what we talked about today. We have 7 best practices here. First, when you're designing your service, you should orient the different requests around the resources, around the types of data that you know you're going to work with. If possible, your service should be stateless. All the information to handle a request should come in when that request is made. You can use request forwarding. It's a very powerful tool to isolate different parts of your code based on maybe the different resources that you update, or if you want to maintain multiple versions of the same interface. You should identify places in the code where you're repeating yourself and write helper methods instead, which are easier to test and less susceptible to problems. If you're only doing updates in one area, you can make sure that that code is exactly right. For handling errors, it's better and a lot simpler to just use exceptions rather than checking for an error at each step. You should use HTTPS on your web server. And finally, if it's appropriate, you should let clients know that it's OK to cache certain response data from your REST service. So that about wraps it up, and I think we'll open up the floor to some questions.
I've had a few good questions here. Can you use other HTTP verbs?
Yes, you can. You can actually use whatever method name you want, as long as the service is written to expect that. So in your URL map, you can have the method equals get, post, put, and so on. You can type anything you want. If the client sends that request and we get a match, we'll call that class method. Now, that doesn't follow the HTTP standard so much, but maybe you have some special situation where you need to write your own different methods to differentiate different operations. But yes, that will work.
Question here. So I think this question is, how do I restrict the data being sent back? As in, how do I make a REST request that limits the data?
Were you talking about query parameters?
Yeah, something like.
OK. So if you're familiar with the query string in a URL, which is the question mark followed by a series of basically key value pairs, different variables you want to send in, you can check for those values, I believe, with the %request.data variable, which if you're familiar with CSP and Zen development, you'll use kind of frequently to grab input from the request. You can do the same thing with REST in your dispatch methods. You can check to see if a certain parameter is defined on the URL and then optionally modify the request information that gets sent back. So that's kind of the convention for retrieving data and then optionally modifying it in some way, or to run queries, let's say. Like if you wanted to run a search on your full data set for a certain string, you would use the query string rather than setting that up with a different HTTP method, let's say.
I have a question here asking about supporting different data formats. They said, that your examples use JSON.
Yes.
What if you have XML? What if you have plain text? What about the other formats they might come in?
Sure. So it's obviously, yes, it's possible to support data coming in or out in any number of formats. We use JSON kind of traditionally with these examples. Yeah, the difference would be that you need to, I guess, first detect what type of data was sent in, and you can do that either by checking the URL. You could have, maybe use request forwarding to say, this is our XML service, this is our JSON service. And so you do things totally differently. Maybe you call down into the same helper methods to do the actual updates, but at the top level, the implementation would be different. And then you just validate that information, like I did with JSON, where we call that %from_JSON method to convert that to a dynamic object. You might do something similar, just to use XML as an example, to parse that incoming data. And then at the end, when you want to send the information back, you would, I guess, use the %XML writer class to build up a document, or you could just concatenate a string if you wanted to. And yeah, it's really about just in your service letting people know what's available. What is the purpose of this service, and what are the data formats that we expect to see? And documentation helps with that.
Actually, on documentation, someone's asking about if there are best practices for documentation.
Yes. I don't have any really concrete details, but I know support for Swagger is being worked on, which is kind of a automatic method for generating documentation for a REST service. I don't have any ETA on when that will be available, but it's something we're looking at. But of course, you're free to write your own, to use that as an example, to write your own Swagger documents. I think the format is YAML for the different,
Yep.
So to have that hosted on your server where the client can then come in and see what methods and different things you support automatically. Maybe you have on your client some tool that pre-generates the boilerplate code to call each REST method. So it would be a good option, not only for documentation, but to support that, to use something like Swagger. But at the moment, you would have to write that yourself. There's no automated method for doing that.
Is there a full example of on-handle CORS request laying around out there? The documentation has snippets. Is there something that kind of fleshes it out more fully?
Yes. Not in my example, unfortunately. Yeah, that's probably something worth putting together. Yeah, that's a good candidate for a WRC case. To
Okay.
Put together an example of that. Yes. And I know the page is a little light on some of the details, but yeah, we can put something like that together for you. Absolutely.
Great. Someone's asking about licensing for this and how the licenses work.
OK. For REST, I know the licensing model is the same as with SOAP, where I think we released the license unit. There's a very small grace period after the request has been processed for the unauthenticated case. I don't know the specifics of that, but knowing that it is the same as SOAP, our other web service technology, that should give you something to go on in the documentation. But if you have a specific question, that, again, might be a good option for a WRC case.
Right. And if you're asking for the other type of licensing, it is just a your normal cache license will get you this functionality. You don't need a special license for REST.
Right. Yes.
Yeah. Oh, someone's asking what version they need to be on to run your example.
OK. That would be 2016.2 and later, because we use the dynamic object API, which is a bit more recent addition to the product. The core REST functionality is available starting with 2014.1, but you'll need to do different things to have JSON information sent back and to have the automatic parsing of the incoming JSON.
Someone's asking if you're using the Zen auxiliary JSON provider.
I am not, because the dynamic object API replaces that for converting to and from JSON. So if you are running on versions between 2014.1 and 2016.2, the Zen auxiliary JSON provider, that was the older utility class for converting to and from JSON. So you would need to use that. But my example uses the new API, which is compatible with 16.2 and onward. My name, again, is Michael Smart. And if you want to email me, my address is msmart@intersystems.com. And Kyle, you give him yours? OK, so Kyle Baxter right here. That's K Baxter, K-B-A-X-T-E-R, @intersystems.com. And I guess we'll stop it right there. I want to thank you for watching and joining us today. We hope you found this session useful. And please go ahead and let us know. There was a survey for you to fill out at the end there. And of course, the developer community is another great resource for asking questions. It can connect you to other InterSystems developers, not only within InterSystems, but your fellow customers. And so finally, for myself and everyone here in Cambridge, thanks for watching. We'll see you next time.